Many organizations use databases to store product information, for example, to specify components that might be used in a variety of projects. The ability to use that information to help in creating new systems is an important use case, particularly if the information in the system model can be updated as the contents of the database change over time. In this video, we show how to bring component information from a MySQL database into a Rhapsody SysML model and update it when required. We assume the viewer has some experience with MySQL. If not, Appendix 3 of the Zendaya tutorial has some introductory instructions for creating, viewing, and editing database contents. To set up this example, we have created 3 tables in a MySQL schema named Instruments, using the MySQL Workbench interface to interact directly with the database. We have also set up a linkage using the Zendaya Repository Manager that gives us access to those tables. Looking at the contents, we see the 3 tables, each of which has 3 rows describing some available components of type thermal camera, visual camera, and radar. Each table has 4 columns, with values for mass, cost, ID, and name. Going to the Connection Manager, we set the connection type to Model Transform, the repository to our MySQL link, and drag the table thermal camera onto the MySQL tutorial demo package in the SysML model. A SysML block, thermal camera, is created with 4 value properties corresponding to the table columns, but no default values. Next, we reset the connection type to data map and drag one of the rows from the thermal camera table onto the SysML package. We must check specialization here, and a new block is created. Instruments Thermal Camera TC1, which is a specialization of the thermal camera block, with the table values appearing as the default values. The default name of the new block is a combination of the schema name, Instruments, the table name, Thermal Camera, and the primary key value of the row TC1, which must be unique for each row in the table. We can add a second component to the SysML model, but this time we just drag a row from the radar table into the SysML model using the data map connection type. This creates both the parent block, radar, and the specialization, Instruments, radar, R3, in a single step. Once the parent block exists, additional rows from the database recognize that this block is already connected to the table and does not need to be created again. However, we can't create a second component of type R3 using a second drag and drop operation. Back in the SysML model, we drag the new components into the BDD and make them part properties of the payload block. We'll also use the display option feature to show the value properties. The new blocks in the diagram show the default values. For example, the mass of the radar is 20 kilograms. But in this example, we suppose that this value in the MySQL database has changed, perhaps because of new data from the manufacturer. We make this change through the MySQL workbench, and now we will have a discrepancy across the connection. In the connection browser, we expand the SysML model we can right-click an individual connection, or the element that owns that connection, and select Compare SysML and Target to compare only that connection. But we will compare across all the connections for this package to see all differences. The Comparison Result tab shows a difference for the radar, specifically a mass discrepancy. Assuming that the database is the master authority in this case, we can update the SysML model by returning to the connection browser, right-clicking the instrument radar R3 element, and choosing Sync Target to SysML. Sync SysML to Target would have written the SysML value to the database, assuming our database access had write privileges. Now, returning to the SysML model, we see that the mass value for radar R3 has been updated to 22 kilograms.